Okay, thank you very much. Thank you, Ilya, for the intro. Thank you for coming, and especially to the crowd on the left. I see you. So yeah, I'm here to talk about large-scale data processing and how we do it at Foursquare, and especially to pay attention on the orchestration and scheduling perspective on it. So first, shortly about me, as Ilya said, my name is Dusan. I'm engineering manager here. I'm leading the movements team here in Serbia. I'm data engineer and architect, building data platforms since 2016, roughly, and dealing with orchestration problems since 2013. That's the first time I started working in data engineering, and it was big data back then. Yeah, something that I want to, touch upon in the beginning is historical development of Foursquare. So, as Ilya said, Foursquare was founded in 2009, and first it was a check-in app. I was a happy user of that app until it got renamed to Swarm. Then, for some reason, I stopped using it. I don't know. And then around 2019 and 2020, there was a lot of things happening. Foursquare acquired first a company called Placed. It was actually a location-driven insights and mobile-led intelligence platform. 2022, we acquired Factual, which was another location data company, and finally at 2021, Foursquare acquired Unfolded, and this is how, through this organization, Foursquare actually came to Serbia. It was a geospatial analytics platform famous for its Unfolded Studio solution, and you will see I used some of the graphics and the images in this presentation to make it more, looking more nice and to look at interesting. These are all visualizations from the Foursquare Studio. Some of them are related to the slides they are put on, some of them are not, but I wanted to use this opportunity to show you the possibilities of Foursquare Studio while we are talking about other things. And yeah, knowing that we have acquired a couple of other organizations, those organizations brought their own technology stacks into Foursquare. And when it comes to orchestration tools, they brought three different ones. The first one I want to mention is a tool called Elmer, which is in-house built tool. It came from the Placed organization. In fact, what does it do? It's a Ruby library. It uses Jenkins as a running platform, and it uses Jenkins as a scheduler. It sends work to AWS EMR. For those who don't know, EMR is AWS service, Elastic MapReduce. It's used for, you basically send all of your Spark jobs and data processing jobs to EMR, and then EMR executes them. What Elmer does is basically through you have a definition of a Jenkins job, and you put some parameters into that job, and you put some environment variables into that job, and then Elmer as a Ruby library takes all of those into account and basically creates EMR configuration, really long and big JSON, and puts it to, sends it to EMR, and then EMR creates a cluster according to that configuration. The other one, obviously Elmer has its own quirks, but it has also some very nice features. That's it tackles certain aspects of the organization, orchestration and scheduling. However, original Foursquare tool for the orchestration was Luigi. As some of you may know, this is developed by Spotify and then open sourced. It's a Python framework for data processing flows and batch jobs. It's really powerful. It takes a lot from developer taking care of what should be executed before something else and what goes after something has happened. So it defines two I would say, major functions. It's requires and output requires defines which jobs should be executed prior upstream, and the output defines where the output of our job is going. And the third organization, Factual, brought in Airflow. Airflow became, along the way, I would say, industry standard for scheduling and for orchestration. It's based on the DAGs, directed date cyclic graphs, which are made of tasks, and dependencies between those tasks are defined in Python files. So basically, you are coding your orchestration. We could say this is like orchestration as a code. If we have like infrastructure as a code, this is orchestration as a code. And yeah, those DAGs, those pipelines, if we call them like that, can be executed on a schedule base or on external triggers. I wanted to show some numbers here because I think it's really important to, since I titled the presentation Orchestration at Scale, I wanted to show you some numbers. So I did some counting, and in the moment when I was counting this, Elmer was scheduling around 650 jobs in total. Out of those 650, 250 were EMR pipelines. So only Elmer deals with 250 EMR pipelines that are running in Foursquare. Now, this I want to make a distinction here. When I say 250, this is not 250 jobs. This is 250 pipelines. So these pipelines can have one job, or can have, I don't know, 20, 50. Depends on the complexity of the pipeline. Also, Airflow. Right now we have 500 DAGs. These pipelines, yeah.
Explain the partnership, right?
Which one?
EMR.
EMR, that's the AWS EMR service, Elastic MapReduce, directed acyclic graphs. Yeah. So we have like 500 DAGs in Airflow. That translates into roughly 4.75 million of tasks per month. So basically, for Luigi, I didn't count because I was thinking these numbers are big enough. But what does it mean? It means that I personally was in a situation that when I did some development and I created EMR cluster, I did something on that cluster and I wanted to check how the cluster is behaving. I wanted to see ganglia. I wanted to see, the Spark execution, and that was, let's say, roughly after half an hour that cluster was doing something. And then I went to AWS console. I was looking for my cluster and I couldn't find it because so many clusters were created in the meantime. My cluster was gone from the list, so I had to spend some time to click to find my cluster. Now I have much better ways of finding my clusters. I actually keep an URL of any cluster, and then I find the ID of my cluster, and I put it in the URL, and then I have it immediately. So I don't scroll through the list. Yeah, so this is the scale. So I would say we have easily over 1K pipelines that are running in Foursquare. And you can imagine having 3 different orchestration tools. That's a pain of maintaining these tools that are quite different. Elmer being in Ruby, Luigi and Airflow being in Python, but with totally different philosophies how they work. That's tough. So we decided we are going to go with Airflow, and we are going to unify all those pipelines into Airflow and have Airflow as a single orchestration tool. Of course, as influencers would say, many of you ask me why we did this, why Airflow. So Airflow, because we have the most in-house knowledge about Airflow, and that's I would say, the most expensive thing. Losing time of educating many people how new tools are working. So Airflow was the strongest here. Airflow has a great visualization of the DAGs. You can see here one DAG that has a number of tasks, and we can see a number of executions of it. We have those lines up on the top of the image present the running time of that DAG. Green ones are the tasks that are executed successfully. The pink ones are, I think, skipped. So it has a great visualization of each run. Airflow is highly customizable because it's Python. You can write any of your code in Python and put it in your DAG, and that's it. That's the customization that you have, that you need. It's also highly scalable, and it can be deployed, of course, in different manners. But how we deployed it using Kubernetes cluster, it's highly scalable, and it brings a number of integrations packaged together. So it has something that's called Airflow provider packages. So you have like AWS provider packages, and with that package, you can talk with all of the AWS services, and whatever you need, it's already over there. Those were some of the reasons why we went for the Airflow. And then, of course, with any tool, you can make mistakes. And while I was working in the data platform team of Foursquare, that's where we learned that with Airflow, you can make a mistake, you can make an error that can cost you very much. So I would say that one of the most common issues and the pitfalls is doing too much at the top level of the DAG. And to understand why this is a mistake, you have to know how Airflow is doing its job. What Airflow, you have your code, which is your DAG. So basically that Python code represents your pipeline. You deploy this to Airflow, and what Airflow is doing is every, couple of minutes, depending on how you configured the Airflow, it reparses those DAGs, checking if there were any changes. Anything that is on the top level of that DAG is actually going to be executed every time that Airflow parses that DAG. So you can understand that the Python code that represents the DAG is actually kind of a script that is being read from the bottom from the top to the bottom. So basically, it's like you're executing the top level of the DAG anytime you pass the DAG. So what that means that if you put a communication with the database, for example, on the top level in the Airflow DAG, that happens every 5 minutes or every 3 minutes, whatever you set for the frequency of the refreshing. So you may say, but that's okay. That's maybe one call to the database. But then that's why I put that slide with the numbers of the DAGs. If you work on the Foursquare scale, you cannot allow that to happen because you always have to think at scale. You cannot say, but that's just one database call. That's not one database call. That's 500 database calls or 1,000. So you always have to look things that way. Also, one common pitfall was reducing parsing time. So that parsing time that I just mentioned, 5 minutes is okay. What that means? That means that developer pushes their code to GitHub. There is a PI. We approve the PI. We click, we want to merge. There is a continuous integration happening. And once everything is done, that code gets merged to the main branch. And then we wait, let's say, 5 minutes for our code to appear in production, right? However, if the interval of the reprocessing all the DAGs just ended, you will have to wait your 5 minutes. That's the worst case scenario, right? But you maybe, if you are in the middle of that interval, you will wait for 2.5 minutes, right? But some of us are maybe sometimes impatient and we want to get our code into production immediately. So we might fall in the trap that we want to say we are going to make Airflow reprocess all the DAGs on every minute or 30 seconds. What we actually had as a situation is that our parsing time was shorter. No, sorry, the interval between the parsing times was shorter than the parsing time itself, which means that Airflow was constantly doing something. And the problem is that it's the scheduler of the Airflow that is doing that work. So now step back. How Airflow is designed. It has a scheduler, which is scheduling all the jobs and which is doing this this parsing, and it has the workers. The workers are created every time. One worker is one task that is executing some logic from the DAG. What happens here is that scheduler is working all the time, and it's under load, making it slower in scheduling the real work that needs to be done. So the solution for this was to simply increase that parsing time and then put some load off the scheduler. And then there is another one. And so before going into this one, I want to define some things around Airflow. Airflow is using something that is called pools. Pools you can understand in the same way as connection pools. You have a pool of 10 connections, and when you want to use a connection, you take that connection from the pool. When you don't need it anymore, you put it back. That's what also Airflow has. But this is the pool of the slots which can be used for like putting the task into those slots. And then when the tasks are put there, they are actually being, scheduled, executed, and they are in some useful state. However, if your DAG is using too many slots, it's consuming all the bandwidth that Airflow has. And that could lead to situations in which you are being too greedy with your DAG, you're taking too much of Airflow, other things cannot happen at the same time while your DAG is running. So solution to this is create another pool with another number of slots. And why is this important? This is important because this way you are controlling the level of concurrency, which means that in one pool you will have a certain number of slots and things will be happening over there. However, in the another pool you can have a different number of slots and some other things can be dedicated to that pool. So that's how we were solving that problem. Oh my God, we have more. So one major, this is really a nice one, easy to catch, but amazing to solve. This is a misuse of sensor scheduling. So Airflow has two main, I don't know what word to use. It has operators and it has sensors. Operator is actually something that is going to become a task. This is something that is going to be executed. It can be Python operator, which is running any kind of Python code. It can be Kubernetes operator, which is starting a Kubernetes pod and running something over there. It can be, I don't know what we have else, but like any type of task. Sensors are special type of operators. They are not doing anything other than waiting for something to happen. So if you have like a, I don't know, you could have a sensor that is waiting for some file to appear somewhere. What it does, it starts executing and it's waiting until it can find the file somewhere in some location that you specified. When that file appears, the sensor says, okay, the file is in place, I'm shutting down. So where we use sensors? We use sensors when in the moments in the pipeline when, for example, one pipeline should start after the another pipeline, but we don't want to rely on the running times because maybe we miss. So maybe the first pipeline will not finish in the time when we schedule the second pipeline. So what we do in that moment, we make first pipeline, for example, push a file somewhere, and we make the second pipeline wait for that file. In that moment, the second pipeline will start running, but it will not do anything until the file is over there. Now, what's the misuse of sensor here? If you are sure that something is going to happen, like for example, this file is going to appear in the place where you're waiting it in a matter of seconds, then you should schedule your sensor in one way. If you don't know when it's going to happen, if it can happen, you wait for hours, then you should schedule it another way. Why? Because sensors are, as I said, a special type of operators. They are going to be scheduled in a slot of a certain pool, right? And if you schedule it as in a poke mode, what it's going to do, it's going to, for example, check for file. It's going to check for file every 5 seconds, let's say, or 30 seconds, doesn't make any difference. So it's going to check if the file is over there. It's going to poke the location every 30 seconds. However, it's going to keep the slot busy. It's not going to give the slot back to the scheduler. So if you're waiting for longer times, then you want to run your sensors in reschedule mode, which means like, okay, I'm taking the slot, I'm checking if the file is over there, the file is not there, I have to check more, I have to wait more, then I'm going to die, the sensor dies, returns the slot back to scheduler, and then after a minute or 2 minutes or however you configure this, scheduler reschedules the sensor, and then sensor does its work again. So that's very, very useful in situations where you are waiting for longer periods, and this is how you, again, keeping your airflow capable of doing many, many things at the same time. And this one is also very nice. That's I call it heavy operators, heavy in terms of computationally heavy. This is something when you schedule, when you create a task that is doing some really heavy computational work, which is, in my opinion, should not be there, because that way you are making your airflow infrastructure doing heavy computational stuff. You should move that out of the tasks. You should move that out of airflow. I think it also breaks the separation of concerns concept, because airflow is scheduler. It's an orchestration tool. It should be doing orchestration. Should not be doing computation. This Grafana panel presents greedy DAGs. As I said, those are DAGs that are using many slots. The yellow line, like the most upper line, is actually open slots over time in Airflow cluster. What you can see is significant drops in certain moments. That's where those were happening when a certain DAGs with many tasks asking for too many slots were being triggered. So solution for this was to use different pools for those tasks and basically move them out of the default pool, which everybody is using by default in Foursquare, in Airflow. This one, I think it's tightly related to how we do things in Airflow, or let's say how we did. I already explained how we push data, how we push our code to production. So what we do, we create a PR, a pull request. There is an approval on that pull request. Then there is a whole process of testing it and continuous integration. And then this is merged and it's in production, right? But every time scheduler schedules a task, that particular task downloads the repository of the DAGs and runs one particular task from one particular DAG inside of that repository. This is our scheduler heartbeat. You can see the yellow line is the number of is it this? Yeah, this is the heartbeat. So this shows that we had actually problems because we couldn't schedule, and the scheduler was failing because of this. It was actually constantly trying to restart itself because GitHub was down. So I mean, this happens once a year, but it happened, and it depends how long it lasts. If it lasts like what is this, like an hour and a half, maybe it's okay. But if it lasts longer, this could have significant consequences for our deliveries, because Airflow is orchestrating also our data deliveries and everything downstream. This one is my favorite. This one is my favorite, and it shows the Airflow database under heavy load. So again, to take a step back, Airflow as an orchestrator has its own database where it keeps all the executions, all the DAGs definitions, all the tasks that were scheduled, all the parameters that are running between the tasks, that are shared between the tasks. So everything is in that database. If that database is under heavy load, the scheduler and the UI of the Airflow cannot get what they need from the database. So they are sending the SQL queries to the database, but they are not getting any responses. And what they are doing in the meantime, they are waiting, which means that they are not doing their job. And why this was my favorite? It was my favorite because it happened some minutes after 2 a.m. on my watch when I was on call. And if you can see, it lasted for 6 hours because I didn't know what to do at the time, so I was awake all night. But finally, it got to me sometime in the morning. I will check what database is doing. We never had this before. And after I realized that there are like normal situation was that we have 30 to 50 queries running against Airflow database at any moment. But when I realized that we have, I think, over 200 queries trying to do something on the database, and when I killed 150 of them, with my fingers crossed, everything started working properly again. So this is, I wanted to kind of show how this is done. This is the query that you run on the Airflow database. It will give you the list of all queries with their running times, and then you order them by duration. And if you see queries that are running for hours and are still in some pending state or waiting for commit or whatever, it's most likely that those queries will not happen. However, don't rush into killing them with this, because make sure that you have in the list of the running queries, make sure that you have the same query somewhere in the lower portion of your list of running queries, because you cannot just kill query that is trying to do something. You have to, you have to let it finish. And if you have 50 of those, kill 49 of them. Leave the youngest one. That's my suggestion. That's what I do. That's what I did, and it turned out okay. And this was the culprit of everything. This was the DAG that caused problems for us. So all of these bold names are actually task groups. So first and second and the third column are the task groups, while you will have only in the third one, I managed to get to the actual tasks in those tasks groups. So you can see here that we have a task group which has a list of task groups, and then the hierarchy between those was very, very complex. And then when you basically, think about it, what it does, when you open a UI of the Airflow, that was already enough to put some stress on the database, because the query to get all this printed on the screen is already problematic. And then, again, back to scale. If more people are opening this, that's a problem. And then what usually happens, because we are impatient by nature, I would say, you try to open this page, and then in a second or two, nothing happened. And then what you do, you click refresh. And what you did by that is you just sent a couple of more queries of the same nature to database, and basically you are cutting the branch that you are sitting on. And this, I think, is the last slide of the presentation. little letters in the upper left right corner saying disclaimer, this is personal opinion, and this is I think Airflow is a great tool. It's really extensible, it's easy, customizable, and that's by design. However, as I presented in this presentation, you could extend and customize Airflow in a ways that are terrible, and you could really create some problems for yourself. And I think it's a tool that is designed in a way that, in order to use it properly, you really have to understand how it's working and what are the internals of Airflow. Because if you don't do something that feels natural to you, would actually not be a proper way to do it, and it will create many problems, and you will be wakened during the night. And that's it. No questions.
Any questions for Dusan?
If you don't have any questions, that means I did a terrible job.
No, you did excellent job. Everything is clear. Okay. If there are
There is one. There is one.
This one? Great.
Hello, thank you for great presentation. I'd like to ask, in the beginning of the presentation, you said about that Foursquare acquired 3 companies,
Yeah.
and I feel like I'm not, well, I should have researched before, but
Okay.
consider that I don't remember. What does, or what did, what kind of services those companies provided? So how M&A deals enhanced value Foursquare, which Foursquare gives to their clients? Thank you.
I have to disappoint you.
But maybe
Yeah, I don't know. I have to disappoint you because I'm not that deep into that side of business, so I couldn't really, give you a proper answer. And I don't want to misinform.
Maybe Jason?
that's what.
What did the 3 companies that we acquired brought to Foursquare in terms of technology, market share?
It's like you. Yeah.
Yes.
I mean, each of them satisfied
Thank you. Each of them satisfied a kind of a gap in our offering. So when you think of a geospatial platform, you think of data acquisition, transformation, and then different presentation layers. So you could think of Unfolded. We needed a visualization layer. We have geospatial data is very complex. We needed a way to represent this data outside of just columns and rows. So Unfolded was acquired to provide that presentation layer, give developers an opportunity to either bring their data and our data, and then produce interesting insights and visualizations. Similar with the like our marketers business. So satisfying geolocation needs for advertisers and marketers. So Factual provided that attribution and targeting capability that we really needed.
So regarding scheduling, you were talking about when you push a change to the repository, you have to wait several minutes, half of the scheduling time. Is there a mechanism to maybe have sensor or something like that detects if there's a change, an immediate change required that stops executing of the current task and kind of reruns it immediately when you do it?
I see. Okay, so let me explain this. So when the code is, let me repeat that again, because I think the whole flow is important. A PR is created, it gets approval, it gets merged, then everything is before it gets merged, everything is tested, and then it gets merged into main. Now, at that moment, some tasks are already running, some are about to be run, right? So what happens is that in that moment when that's merged into main, the first next task that is going to be scheduled is going to pick up that change. That's the way how it does, right? However, if you try to stop everything, that's not very good idea, because why? If you stop everything, then you have to have a mechanism. Now I'm thinking while I'm saying. So you have to have a mechanism to track what you stopped. And then if you go back to my point of separation of concerns, you have pipelines that you scheduled from Airflow, but they are working in asynchronous manner somewhere on EMR, for example, and those pipelines can be hours long. And it's one thing if you stop the DAG, that's one thing, but these are still running. So if you really want to be kind of a good citizen, you have to kill all of these. But what you did then is you stop them in unexpected time. You don't know what's the result of them. Maybe some intermediary results are already written, maybe they are not. And also you wasted all of that time that was running, because with 500 DAGs running in Airflow only, if I make a change and I kill 499, I wasted a lot of time for those. So we are just, the next run of my thing will pick up the change and will do the thing.
Maybe to simplify the question, is there a way to optimize the waiting time by making it event-based and not like waiting for it to pull?
I would say no, because the time that you are kind of trying to tweak, for your basically the compromise between your waiting time and the parsing time depends on the infrastructure that is running the scheduler. So if the node that is running your scheduler is powerful, you can probably shrink that. However, if it's not, you have to give it some more time.
Okay, thanks.
Cool. Good question.
Okay, thank you. We're gonna do a short 15-minute break, and after that, Marshall Yunt will give a tech talk with the theme of refactoring your role, the engineering guide to careers development, less technical than this one, so please stay for the next one. Thank you, Dusan.
Thank you.